go ahead and get started. I know there's still people jumping in, um, but just to introduce myself, my name is Dave Eckroat. I am VP of Sales and Operations for IDEA US. With me today, I have Andrea and Johan, who are more of our technical people here in the US office. Today's topic for the webinar is group load design, deliver all your connections in one go. And really, I think looking at how IDEA has been perceived, real globally to start, it's always kind of been looked upon as a solution for complex connections. And really, what we're going to show you today is just that it really can be used for all of your connection designs. From the most simple to the most complex, and kind of still be able to save you a lot of time. So next slide. So just the general housekeeping, I'm sure most of you have been on GoToWebinar before, but if you have any questions, just feel free to open up the questions tab in the control panel and type that in, and we'll be doing the Q&A at the end of the session. In addition, there is the handout that's listed there or uploaded there. So just basically the PowerPoint presentation, if you wanted to grab that as well. So next, so just looking at the agenda. So as I mentioned, kind of being able to design all your connections in a project, and really what makes that possible is the use of our Checkbot tool. So we'll kind of introduce Checkbot, discuss the grouping and batching for connection design within the software, how it brings over critical loads, or how you can create critical loads for your connection groups. We'll look at the reporting from Checkbot. So, basically be able to create a single report with all the connections from your project. And then also discuss how you can take an IFC model from Checkbot into your BIM tools. And then finally, we will have a Q&A. So next slide. So just as an introduction for IDEA StatiCa, our main product has been the steel design tool. So that would be your connections, which we'll be talking about extensively here, along with member, which is really meant for kind of some critical member design checks, primarily lateral torsional buckling analysis. The difference between this and maybe your standard analysis tools is that you're able to model the connections within member and take that stiffness into consideration in checking the member design. The next thing we have on the list is detail. So this is our concrete tool for the ACI code. So really it's meant for analyzing and designing discontinuous regions in concrete members and walls. In addition to that, we introduced it last month in our webinar as far as the workflow for anchorage. So using the connection and detail software combined. So as you can kind of see in the graphic, being able to design your base plate, then take that information to detail and design and model your concrete reinforcing within detail. So definitely a nice workflow that we have within the software for that situation. So now if we look at kind of the integrated connection design workflow, IDEA, we are an independent company, so we do play nice with all the other structural engineering software vendors. So you can see a list there on the left of some of the tools that we link to. That is not all of them. I think we have about 25 or 30 different analysis tools that we link with currently. So basically what you can do is you can take your analysis model using Checkbot, bring that into IDEA. It'll bring over loads and geometry from your model. From that, you can then start to design your connections. So then you have a choice. You can either design specific connections. Maybe you only want to look at your lateral connections. So you can easily kind of just look at those. You can look at those individually, or you can use some of the grouping tools that we're going to be discussing today to kind of be able to batch design a bunch of connections. And then finally, just kind of as far as the deliverables, we do have detailed reports, calculation reports, bills of material. You're able to create some sketches within the software itself of specific connections. And then finally, as we'll talk about in a little while, we'll go through and show you the IFC reference model that you can create from IDEA, or even some 3D drawings, typically through the viewer or directly in the connection app itself. So next slide. So for today's webinar, we chose this as an example project. Relatively simple, one-story structure. So we have 118 joints in this model. It's approximately 200 connections. Unfortunately, I just did not sit there and count up each individual connection, but I'd say we're about 200 in this model. So the question is, how long would you spend to design all the connections in this project? And so we're going to run a quick little poll here. So let me go ahead and launch that. Okay, so now there's a poll. We'll leave that up here for a minute or so, just so everybody can kind of answer. Just give it another 15 seconds or so. Okay. We'll go ahead and close the poll. And what I'll do is I'll just share that so you can kind of see the answers. So relatively, evenly distributed. Most people are saying it'd be 6 to 12 hours to do, 200 connections for that type of project. Next would be more than 24 hours, 12 to 24. So generally, the majority of you said that this would take you more than 6 hours to design all the connections within this project, with a lot of you saying, even more than that. So I'll go ahead and hide the poll. And now I will hand off, and Johan will take over and walk you through the process. Thanks, Johan.
Thank you, Devs. No problem. So we'll go ahead and start with a quick demo showing you basically the possibilities that Checkbot can offer by basically using this workflow. Now, as mentioned, you can start with any software and integrate with our plugins. These plugins are basically available either on our website or directly within the desktop application. Now, in this case, for this demo, we're starting with STAAD.Pro, but once it gets into Checkbot, the workflow will be the same no matter where you started with. So if we'll go ahead and get started with the demo video. Again, here we're starting with STAAD.Pro. And since we already have the plugin, we are able to call in upon Checkbot, and all we have to do is basically import that selected geometry. We already had it selected on STAAD.Pro, so now all we have to do is import it. So as mentioned, once it gets into Checkbot, everything from here on will be the same no matter where you started with. And if we just stop to take a look at into what was brought in was basically the entire structure. So as it was in STAAD.Pro, as you can see, it's generated essentially the same. And one of the first things that happen here is IDEA StatiCa will automatically group all your different nodes into their own respective set of group nodes. Now, the way that we group them is we're grouping them based on the amount of members, their cross sections, and their geometries, so that we can be able to identify the similar connections a lot faster, so that you don't have to waste time grouping them by yourself. So in this case, what we're going to start doing now, we are going to start reviewing our joints in the groups. So if we start with basically looking at group 1, before we start looking at the groups, if we start looking at the entire connections or the entire structure that we brought in, as you can see here, once we click on connections, we can see the entire information. So here we brought in 118 connections. So those are all the different joints that we brought in. So within that one single joint, we could have multiple different connections. So per se, we're looking at this more complex node. We have some beam to beam to column, brace connections all within that one single node. So that's what we mean by a connection. That's basically a node. And here you have the status of your entire project. So we have 118 connections to be designed. Since this is an empty or a undefined project, all of them are set to be designed, and because of that, none have been checked and we don't have any results for them. But as we keep modeling them and analyzing the groups, we'll start to populate these results, and you can see the status as you keep going. So if we keep going on this video, we can start looking at basically the information per group. If we start looking at group one of the first things that you'll notice is that once you select on any node or a group, those nodes, those will be highlighted just so that you can find them within the model a lot faster. So if you select a node within a group, that node will be highlighted in orange, and the rest of the nodes that are within that same group will be highlighted in yellow. In this case for group one, as you can see, we have our outer nodes that are composed of one member, and those nodes are basically for those base plate connections. Now here on the right hand side, we have some more information for that specific group. So here for group one, the type of information that we can find are the group name. So of course, aside from it being labeled group one, you are more than welcome to rename it. You can always rename it based on the type of connection that you're creating so that you can find these groups a lot faster. If we keep moving down the list, that reference connection, this is basically that key connection that you will be involved with in Checkbot. So in this instance for group one, our reference connection is 372. And as you can see, that is the very first node or that first connection that we have within this one group. So what's so important about this reference connection is that this will be the main connection that you have to model, that you will be modeling within Checkbot. And thanks to that grouping feature and this batch design that we have, all you have to do is model that single connection, and that same model gets automatically applied to the rest of the connections that are within that group. Since all of these are similar connections, that same model that you did within the reference connection will be applied to the rest. If we keep moving further down this group, we can see that within this one single group, we have a total of 8 connections, and we have under the topology of or what makes them similar, it's only one member. So here, if we start to think about that reference connection, we're already minimizing time with this. We are already automatically grouped all of these nodes. We already identified the reference connection. So instead of having to model all of these 8 different connections, and even an avid user, if users already know about saving connections using connection library, you're also saving this time from having to do those steps individually. Here with Checkbot, all you have to do is just model one, and you don't even have to do those additional steps of applying the connections. All you have to do is model it once, and Checkbot automatically applies that model to the rest of the connections. So just to keep on mind the time savings based on the modeling aspects. If we keep reviewing our groups, it becomes a lot more apparent as we will have more connections. So for group 2, we have a total of 12 connections. If we keep going further down, for these group 3, as you can see, these are all beam-to-beam connections. Although these are very simple connections, we have a total amount of 32 connections, and from there we only have to model one connection, which is our reference connection, connection 63. So here, again, we're minimizing time by auto grouping and by only having to model our reference connection. We can also keep going further down to inspect the rest of our groups. As you can see, these are grouped correctly based on their topology, so you can ensure the same design will be applied to the rest of the connections. And because we are highlighting these groups, this will help us find our connections within those groups. So because of this, we're able to identify these 4 brace connections that fall under group 8. And if we want to take a look at the more complex connections, as you can see here, within group 13, we can identify these more complex connections, which are at the middle for these nodes that are composed of multiple connections. Now, once we have inspected the different groups and the different nodes, we can also do a more in-depth inspection of each and every single connection so that we can see the detailed information that was brought in. So in this case, we are going to look at the detailed information for that particular node within group 1, which is connection 374. So all you have to do is click on that node, open it, and now we are within or inside of connection. So here under connection, we can identify that or verify that we have brought in our geometry, our cross sections, our members, but something additional and more critical is that we have brought in the load effects. So here you can see that we brought in the entire load effects for just that one single connection. So in this case, we only have 7 load effects, but in other cases, as it's understandable, you might have maybe 20, 30, or even over 50 load combinations that will be applied for a single connection. So in some cases, it can become a lot of load effects. And if you think about it, if you're trying to run all of those load combinations for a single group, having a total of just 8 connections, that can become already a lot of analysis. But with Checkbot, one of the newer features that we added into Checkbot is the availability of being able to activate this feature, which is calculate load extremes. So with calculate load extremes, what we are doing is basically identifying the critical load effects that are going on within this single group. So within this single group, we have 8 connections. We're identifying our critical connections, and from those critical connections, we're also identifying the critical load effects. So for this group 1, if we start to take a look at what we have optimized, we started with 8 connections. Instead of modeling 8 connections, now we're only modeling our reference connections. So from 8 down to 1 in modeling. In the analysis aspect, if we're starting with 8 connections, every connection had 7 load combinations. So that in total is over 50 load combinations. But by activating the critical load extremes, we went down from 8 connections down to 4 connections. And even lower, we went from 7 load combinations per connection to a maximum of 2 critical load effects per connection. So we cut that time way under half the time that it would take by analyzing each and every single one of them separately. Now this is just for this group 1, which contains only 8 connections. But if we go to this group, which is group 3, we're starting with 32 connections, 7 load combinations each. If we activate load extremes, as you can see, we went down from 32 to 17 connections that have been designated as critical connections. And per every critical connection, as you can see, we only have 1 load effects, maximum 2 load effects per combination. So all of these optimizations, all of these features that we're activating will only allow you to be able to move through these connections a lot faster, focus on what's critical, and be able to model each and every single connection safely. So as you can see, we're activating the load extremes for all of our different groups. You can see how we're minimizing the total amount of connections that not only have to be modeled, but the load effects that have to be analyzed. So once we did the load optimization, now we can go ahead and start modeling our reference connections. So in this case, what you can see here is we now have only the critical load effects activated within the connection. The rest of the load effects have been deactivated because they're no longer critical load effects. So from here, we can start modeling the connection. If you have connections that you have designed in the past and you're using connection library, you can do that, but you can also start from scratch by using operations. And again, with our operations, these are all fully customizable. You can always edit all the different parameters within our operations. In this case, we're only editing the anchors. We're adjusting the anchor length. You can also adjust the boundary conditions for all these members. Once you're satisfied with the model, you can always just click save. So you can save the model of this connection and you can exit Checkbot. Here is where you'll perform the analysis, but not just for that one connection, but for the entire group. So here, if you think about it, we only model the reference connection. We already activated the load effects for the load extremes, and now we're calculating all the connections. Now, one of the things that you will notice here after calculating all the different connections is that we have a status bar. So here on the left-hand side for every single connection, you'll see either a check mark for the passing connections or an X mark for any connections that fail. And additional status will be this dash line, and this is basically the connections that are non-critical for the analysis. So since these are non-critical, they don't have to be analyzed because by default, they will be passing the analysis since we are analyzing the critical connections with the critical load effects. So if we keep going on to the different groups, for group 3, we can repeat the process. We'll start with the reference connection. We'll start modeling our reference connection, either by scratch or by using connection library. In here, we can start adjusting the parameters. And once we are satisfied with these parameters, we can also adjust the boundary conditions just so we can ensure the correct forces are at the correct location. We'll go ahead and save it. We have our load extremes activated and we can run the analysis. So here, instead of analyzing the 32 connections, we're only analyzing 17 critical connections with only 1 to 2 critical load effects each. So from here, we're running all of this analysis and we have our status for every single connection, either check, X, or a dash mark based on whether they passed, failed, or they're non-critical connections. Another quick rerun here for a little bit more of a complex connection, a double-sided beam-to-beam connection. As you can see with IDEA StatiCa, all you need to do is just use one operation, just because here we have the availability of referencing 2 members at once. Additional things that we can do here is maybe adding a splice connection to the top flange of the beams, just so that we can reinforce them during the analysis. As you can see here, we can add independent bolt operations, so you're not restrained to those single operations. You can always combine them to be able to create your own connection. So here, as you can see, we're looking at that none of these load effects have been checked, because even though this is a reference connection, it was not deemed a critical connection. So even though it's not a critical connection, that the sign on that reference connection is still being applied and the analysis is being run. In this case, we already checked all of our groups, all of the connections. So if we want to print out our report, we can print out the report for all the reference connections. All we have to do is multi-select all of them. And from here, we can head on to the report tab. Once you head onto the report tab, if you click generate, you will first get a brief report of your connections, just with a status bar of all the groups and whether they pass or fail. If you want a detailed check or a detailed report of all the connections, you're more than welcome to activate it. Here we'll basically be generating it for the 19 groups that we have here. And as you can see here, we have the detailed report for every single connection. If we scroll all the way down, we'll be able to see basically the ending result, which is our basic code settings and ending results. You have multiple options of exporting this, whether it's a PDF or a document. Now here, if you're working with a detailer, you also have the option of exporting these connections as an IFC file. So here, an IFC file is basically a file that is accepted by multiple detailing software such as Tekla or Revit. And here the advantage is that if you're directly working with a detailer, or if you need to pass on information to your detailer, maybe that connection had to be updated or reinforced and in its changes, instead of having to mock up a drawing, you can always send them an IFC file. So in this case, what we're going to do is basically, instead of sending just one file for just one single connection, we also have the availability of sending the entire project as an IFC file. So we'll go ahead and take a look at it. What we did here is we basically selected all of our connections. They have already been analyzed and been modeled previously. All we have to do is select them all, right click on the connections, and from here we have the option for export. Again, for exporting in IFC files, you have the option of either exporting all of these connections as a single IFC file or exporting them all with their own IFC file. So there will be separated when exported. But for the case of this demo, we'll export them all in a single IFC file. All you have to do is select the location where you want to save this IFC file, whether it be on your project or your detailing project. Just save it. In our instance, we are going to be opening Tekla. So here, if you have an existing project or a completely new project, the importing process will be the same. You'll just go to Menu, Import, and here, since in Tekla an IFC file is deemed a reference model, you can basically import it directly. So you'll just go to Import and Insert Reference File. Here, reference models such as IFC models are accepted. We'll just go ahead and browse for our file that we just saved, located. Then once we select it, we'll go ahead and add this model. And as you will see, the entire structure, basically all the connections have been imported into Tekla. You can go ahead and review. And if you don't need some connections, you can always delete them. On the right-hand side, you have your reference models and you can see all the connections. Now, this exporting process does apply also for Revit, but this essentially basically shows the entire workflow of what you can expect from Checkbot. But from now, we'll go ahead and take it on to Andrea so that she can continue on to the detailed explanation of this workflow.
All right, can you see my screen? I think so.
Yes, we can see it.
Okay, perfect. All right, so now I am going to continue with this presentation. Basically, we are going to review the process that Johan explained with the video, but with a static screen with some slides. You have the slides in GoToWebinar. You can download the PDF and you will see all these examples. So let's review the steps shown in the video using these screens. After importing the structure into Checkbot, this is what you will see in the modeling area. And by the way, there are different steps to bring the model from other applications that you saw at the start. You can find more information in all the tutorials we have in the website. However, Checkbot will always look the same. So you will see the same interface whenever you bring the model into Checkbot. Here in the interface, you will see the next. So first we have the connection icon to import the selected geometry from other applications. Then in the 3D model, you will see the cubes representing the connection item. You can also turn on the groups label. That's also new in the version 25, so you can activate the group labels in this area. And in this area, you will see all the connections listed. You will see the project summary, and the connections, of course, are grouped. And these join groups are defined by number of members, orientations, and cross sections. Now, let's review how groups are defined in Checkbot. The dynamic grouping is an automatic action that Checkbot does once it imports the model. From the model joins, it will arrange the nodes by typology, which is defined by number of members and its orientation, right? And then the arrangements are the second level of groups, which are defined from typologies, and they are defined by cross-section type. You can see an example in this slide of how this is defined, how the groups are defined. From these arrangements, the groups are defined in Checkbot. So those groups will be the base for the batch design. In Checkbot, you can also explode the groups and then create your own groups if that is something you would like to, right? So creating like kind of subgroups. So that is also possible, okay? Now let's jump into the second step that Johan explained in that video. In projects with many nodes and load combinations, similar connections with very similar load effects are analyzed repeatedly. To effectively reduce the calculation time, the calculate load extremes algorithm identifies critical load combination in a defined group of connections, and it speeds up the calculation time by up to 80%. So once you click on this checkbox here, where you're indicating to calculate the load extremes, now only the critical load effects detected in multiple connections can be calculated. All the other load effects in these groups are disabled. But you saw that there are for some connections, all the load effects are disabled. So this diagram here in this area of the slide can help me to explain how this works. So for instance, in group 1, we have this type of joint, which is beam to column, and it has an I section on both elements, right? But the second kind of subgroup in this group 1, it has a higher, a larger, a bigger beam, right? So obviously we'll get higher forces on this beam, okay? So the software, it's going to identify 2 load groups. In load group 1, maybe you have 3 connections. Then from these connections, we identify the load extremes. And then from this load group, we're identifying just 1 load combination, which was the critical. This is just an example, right? Then for the second subgroup, you can maybe have 2 load combinations that were the critical. That's why whenever you see in this table, you have load subgroups and then the critical connection and how many critical load effects from those subgroups you will get, right? So in the presentation, I put some links where it's where we have the detailed explanation of how the calculate load extremes are defined. But this is something we have had before in the standalone version of the software as well. So it's basically identifying the different loads in the member and identifying which is the most extreme. Okay. All right. So one other thing to mention is that the calculate load extremes functionality is available only for Checkbot projects imported from a global analysis software. That means whenever you bring a model from STAAD.Pro, ETABS, SAP 2000, Tekla Structural Designer, Robot. So basically softwares where you have the loads in the model, right? So this is only available for those type of applications. Now, the next step is batch design. The critical loads together with batch design in Checkbot are meant to save design time, as you saw. The steps are very simple. You identify the groups, then you open the reference connection, add a parametric template or use the operations to model the connections in the joint, save the connection, then go back to Checkbot to calculate all the joints in the group. This will copy the reference connection in all the joints, and then you run the analysis for the whole group. This process can save hours of modeling similar connections with similar loads. Once all the groups are designed, now in Checkbot, you can generate detailed reports and create calculation packages in a few minutes. In the video, we show you that you can multi-select some connections by pressing Ctrl and clicking in the connections. In this case, we decided to select only the reference connection, but you can select whichever connections you want, right? After you select these connections, you can go to the Report tab and select the report type. You can create a PDF and get all the reports in one single file. Right, so this is also a new tab that we have in Checkbot. So this is only in version 25. Finally, in the video, we show how to create an IFC file from Checkbot. In the video, we selected all the connections and click on creating one single file with all the selected connections. Later, the IFC file can be imported as reference model into BIM applications like Tekla or Revit. However, IFC is an open file that can be opened in multiple applications. All right, so we're just showing this example for this slide, but you can open it in your preferred application that opens IFC files. One important thing to mention is that the connections have their original coordinates, so this file can help you to detect any clash with other elements in your structure, right? So now let's summarize the example. For that, we prepared this detailed timetable, and I created a line for the different actions we did in Checkbot. And all these actions that I'm listing here were done by group, right? For instance, when we clicked on the critical load checkbox, it took like in average time 1.5 minutes to let the software think and identify the critical loads in the different groups, right? So I'm multiplying the time by group and then by the number of groups, and here I have a column of the total time for each action. The same for the design reference connection. Obviously, this is an average 5 minutes, right? Because there are some connections that are like a shear tab or a double angle connection. As you saw, you just apply an operation, and this is like this will take you like less than a minute, right? But there are some other joints, like the ones in the middle, that they have 4 elements coming in, and then you will need more time to optimize the end plate and then the flange plates, and this will take you more than 1 minute. So that's why I'm using just an average per group, right? So we defined, or we defined it, and that it took 2.5 hours to do the design of all the connections of this project, right? Again, this is just an estimation. Well, this is a real information because I did this example together with Johan. But this is just an example of how long can take you to design this structure and its connection with Checkbot with the new tools of batch design, critical load combinations, and bulk reports. And then compared to what you were responding in the poll, definitely it can help you a lot, right? All right, so now what is the next step? Well, we're proposing you that you start using the new IDEA StatiCa version 25, and then use all the tools that we presented today, right? If you're a user of IDEA StatiCa, if you already have the license, go ahead and download the new version 25. If you're not a user, remember that we have a free trial of 14 days, and then you can start testing this workflow, right? Again, we are sharing with you some links here. So, then you can click on these different links and see the detailed information for every workflow that we present today. Right? Right, Dave? I think it's your time for some other slides, and then we'll jump into the Q&A.
Sure. So unfortunately, I have some news. Basically, we've been working with the current price list since 2023. There has been the decision that we are going to need to increase prices as of July 1st. So obviously everything's kind of getting more expensive. So unfortunately, IDEA is going to get a little bit more expensive for those of you. The nice thing is that you have about a month to get licenses, seats at the current pricing. If you're interested, feel free to use the QR code there or the link to our quote request, and this way you will get in touch with either us or your reseller to be able to get you some pricing and get you the best pricing that you can for for the next month or so. So again, it's not something we take lightly as far as increasing prices. And one thing to mention is just that only affects new seats. That will not affect any renewals or anything like that. If you already are using the software, your costs are not going to be increased per that price increase. Next item that we want to talk about is just some more events coming up. I know Jason is actually in Arizona already for the SCA of Arizona conference this week. I believe it's in Tucson. Jan will be in San Antonio in a couple weeks to give a presentation for the SCA of Texas. I will be at the SCA of South Carolina conference in middle of July. I will be exhibiting as well as giving a presentation on stiffness analysis. So we're definitely going to be continuing to do a lot of the SCA events here in the US. I know we have a bunch on the schedule for the fall as well. We just kind of wanted to give you through the summer. Again, our next we're going to be taking the summer off as far as for the big webinars. So our next webinar will be at the end of August. That'll be based on concrete design. So those are just some of the things we have coming up here in the next couple of months. So with that, I believe we can move on to the Q&A. So,
You're right. I saw some of them. I actually have the model here open. There you go.
Yeah, do you want me to kind of go through and
yeah. Go ahead.
pick some things? So just as we kind of look at some of the questions that came through, I mean, the one is asking about changing rules for making of groups, or can they combine groups within Checkbot?
Combining groups, it's not possible just because it's automatically verifying, like the same orientation and same number of members. However, if in one group, like this one, which is the base plates with an abrasing, maybe you want to have them by frame, let's say. So you can come here and multi-select some of them, and then you can remove it from group. And then later, once they are removed from the group, you can create a new group with those connections that are out of that group. All right. So yeah, that's possible.
Okay. Let's see here. So the question was whether using Checkbot, does it check the stresses for each of the different load cases?
Yeah, I mean, the critical load extremes, it's just to identify the different, the critical loads for the group. However, if we are using one load combination for, let's say, the connection number 63, we're going to use the loads for that specific load combination. We're not combining like shear forces from one load combination from one of the criticals and then axial force from other. No, we're using the actual loads from that load combination. Right?
Okay. Let's see here. So there's a question about kind of integration with the RAM products, whether you can use the Checkbot with RAM structural system, which obviously, yes, we do have the link to RAM structural system. There's a question about RAM elements. Unfortunately, we do not have a link currently with RAM elements. So unfortunately, that's a problem. Let's see. I'm just kind of trying to peruse here. So there was a question about indicating degrees of freedom that you consider in the analysis. How does that get handled within the grouping?
Yeah, so basically you can select the model type for the different members in the connection, and that setup for the model type will be copied in all the other connections in that group. So we're using the same model type that you set up in the reference connection. And then the other question, I mean, that's related to the same question. Like it's like the model type, it's not automatically selected from the STAAD.Pro model because they don't have, well, we're not matching to the information of STAAD.Pro. However, if that connection is only has shear force on the moment input, it's going to be 0. So you don't have to really worry about, just maybe if you have a bracing element, that's where you will change the model type to MBYBC. But bottom line, we're copying the same model type from the reference connection to all the connections in this group. All right.
Okay. Question is whether there's a BIM link available for Revit 2026 at this point. You know, off the top of our head?
I'm not sure, but if you go to the supported integrations link, you can see what are the available version, let's say.
Okay.
Yep. I was trying to.
Sure.
Versions, yeah.
Let's see here.
Still in development, sorry. I was trying to look for, but it's coming.
Okay. Let's see. Just trying to read through the questions here. Let's see. Can you confirm Checkbot will detect and account for transfer forces, assuming the joint is in equilibrium and not using enveloped loads? I guess if it's a good.
Yeah, I think it's not going to use envelope loads. It's going to use load combinations. And actually, you can look at this loads option here, and you will see all the combinations that were imported into Checkbot. So you will look at load cases, not envelopes.
Next question is kind of how if there's a, rather than redrawing the sketches from IDEA into AutoCAD, is there a better way to get that information from IDEA to AutoCAD? Like the connection information.
There is a way to get a 3D drawing from the viewer, and there is also a way to get a DXF drawing from the report. Let me just open real quick one connection and it can show you that. But yeah. And this is also one thing that we didn't mention. You can click over the connection and then export it to a viewer. And then from that viewer, you will be able to download the 3D drawing of the connection. But that will be a 3D drawing.
Okay, perfect. So the question is how, if you can change a member in Checkbot that applies to your analysis model. So can you change like a member size within Checkbot?
You can add a new member here, but we recommend always to change that in your analysis software and then synchronize the model from here. However, if you still want to do that, you click over the member and then you can use this plus icon and then you insert a new cross section for that member.
Okay, All right, this is a little bit of a little different one.
Mm.
Basically, the question is, they have some code form sections that are created in their FE, global analysis software, and wants to know if IDEA identifies those sections, and if it doesn't, can I group the connections myself? So basically, kind of custom shapes. How would that, if you bring in an analysis model with a custom shape, how can you work with that in Checkbot?
Well, at the start, if it's a custom shape, it will ask you to map that custom shape. You can create a custom shape in IDEA StatiCa as well. And then because that custom shape it was mapped, then that will be grouped as well. So we're basically mapping the sections that are not detected by default.
Sure. Okay.
Is that, yeah, that was a.
Can you kind of quickly show in the cross section where we have the custom shapes?
Yeah.
That would be pretty interesting.
Yeah, let me.
Just for the cross section on a general member.
Yeah, like in this case, I am just showing the conversion. Like for instance, there were some sections from STAAD.Pro that it was like combine I section with T section. Then whenever you click over the plus icon and it's asking you to map that section, then you will go to this option here. And that will be the general still cross section editor. All right. And then once you map the section, then you'll have this database here. So it will remember the mapping, right? And then for that question about the DXF drawing, for instance, this was like a gusset plate. You can always request the bill of materials in the detail report, but I am just creating this bill of material report, and then you can send it to DXF and you will get this drawing in DXF, which is an open file to open it in a CAD file, right?
Okay. So there's been a couple of questions about different analysis types and kind of how that would work within the groups, whether it be, capacity design or buckling analysis.
Yeah, if it's capacity design, then the reference connection, you can change that. The analysis from the reference connection, you will change the analysis type. However, it will need the forces, right? If it's buckling, I don't think we can do that yet to run the buckling analysis for all of them. However, like as a workaround, if there is something like specific for that, like for like a bracing connection where you want to run the buckling analysis, I'll suggest just selecting the connections from the group and then export it to connection file, and then you will bring that file with these 4 connections, and then you can run the buckling analysis for all of them. You will get something like this. So you will get multiple project items here, and then you can activate the buckling for all these connections in this IDEA StatiCa standalone version. Right?
Yep. Just one question about whether we can check special moment frame connections per AISC 341, basically the pre-qualified moment connections. Those are able to be done in capacity as a capacity design analysis type. So it wouldn't necessarily, currently you'd have to do those kind of individually. You couldn't group those, correct?
Yeah, I think we can. Like, you'll need to open that connection, let's say this, and then in the reference connection, you will be able to change the analysis type, and they'll copy the analysis type for all these connections.
Okay.
Yeah.
getting close on time here, so we probably just have time for one more question. And I see somebody's. So, I mean, it's the question is how to consider seismic load cases if it doesn't read envelopes. So
yeah, maybe he's referring to when we are doing response spectrum. Yes, response spectrum where you have different like direction of the loads. But if you want more information, please send us an email and I can help you to that. But we're not reading the envelopes, and that depends on what software you're using. So yeah, I can help you with this if you send us an email, please.
Okay. All right. I think we've pretty much gone through. I know there were a bunch of questions about specific additional links to the other software. You know, I think at this point that's kind of something for future development. I'm not sure we kind of have answers on very specific software, but we're always looking into that. And there's always the ability for another software vendor or even an individual company to kind of build their own link using our open API. So let's see. I appreciate all the questions. If we didn't answer your question during the webinar, we will get back to you via email. So I think that is everything. So I appreciate everyone's attention. Hope you found this useful. And as I mentioned, now's the best time to buy IDEA for as the least cost as possible. So thank you very much. And we will see you in August. Thanks, everyone.
All right, see you. Bye.